Another reason why this burgeoning area of reinforcement learning is so interesting to me is I feel like I had, and I've talked about this in other videos, I feel like I've kind of exhausted the paradigm that I have been in for a while. I've like kind of done everything I can with my previous idea about, and this is the subject of I really go into this in other videos that I have posted here. I think just the idea that everything in the world, all these objects that are in our world, can be represented as high-dimensional points, like vectors, essentially, of feature vectors, essentially, of their, if you're describing different properties, different aspects of these objects. And that's like a paradigm for me that maps onto the whole, so many different things in the world. All these different objects, if you describe them in that way, they kind of, they exist in a sense in that kind of high-dimensional space of their attributes. And the way, I guess the way to sum up this idea, the paradigm that I've been really into, I guess, is to say that these, it's the idea of that when you represent all these objects in our world by their feature vectors, these high-dimensional feature vectors will lie on some kind of a data manifold, meaning they're lying on a shape which is like smooth. It's not. They're lying on some kind of a shape that has some sort of, shape to it. It's not like it's uniformly distributed. Like if you just took your X, Y, and Z coordinate and you just sampled each of those from a uniform distribution, you would just end up with a box, a volume. That's not how nature is. In terms of the global structure, like this is, to me, it's like, it pertains to so many things, because it's like the structure of seemingly like everything. If you represent in that way, they will lie. And this is why I was so focused on dimensionality reduction, was because these what dimensionality reduction allows you to do is that you can see that shape, or at least the shadow of it. You can represent all those things and you bring it down into our 2 or 3 dimensional world, and then you can see that there is some kind of an order to all that data. All those objects are kind of connected to each other. Similar objects will be on similar parts of that manifold, and you'll find like clusters, and it's like a probe. It's really like something which allows you to see the unseen world an unseen aspect of nature, which is how all these components, how all these different singular objects are connected to each other. Yeah, so I'm definitely now kind of at a transition point. I feel like I'm at the cusp of a different paradigm shift, where I'm realizing, just in the way that this idea of data manifolds and how everything in nature is like lying on some kind of data manifold, how that maps onto our world and helps me understand our world. I'm now, in learning about reinforcement learning, I'm starting to understand how this kind of paradigm maps onto so many different situations. Basically, it's like you have rewards at every point in time. You as an individual, it's like you have a decision you can make about what you're going to do next, what action you're going to take, and what's the potential value of that action. In reinforcement learning, the agent will sort of receive rewards, or they start in a particular state and then they take some action, and the environment responds in a certain way, which it puts them into a new state. So you take some action and you observe, and there's a component which is the immediate reward that you get from doing that. Like, oh, I'm gonna go out to the club, on this night, or I can stay in and like do some work or something. I don't know. But basically, there's then the idea, of course, because you're moving through an environment, this is like, you can think of it as like life. that will have some downstream consequences which may not reach you for several more steps. Like that definitely caused something to happen, sent you on down a particular path of this like tree. Like I realized that it makes a lot of sense when studying reinforcement learning to kind of visualize the tree of like possible trajectories that you could be going down. From the now. It's like from now it's a spread, it's exponentially spreading out the number of different pathways. I think you know what I mean by that. What happens then is like, if you, by taking some action, you get to a state later which you receive some reward. There's many, oh my gosh, there's so many different algorithms that exist, different ways of tweaking this main idea of reinforcement learning. But basically, in a lot of them, one of the ideas is like, if you take some more steps ahead and you reach a reward that happens later in time, you can then sort of propagate that information backwards to kind of attribute credit or blame to the action that you took, several steps back. In a collection of the algorithms that would be achieved through something called the eligibility trace. Basically, you're allowed to reinforce the change that you had made to your model's parameters, but at a later time. So if you come upon a larger reward later, you can go and do more of the previous modification that you did to your model. Whoa, shoot! Oh my God! Oh my God! Oh man, yeah, that was scary. Yeah, these holes have I think it's some kind of animal. So wrapped up in thought I was not paying attention and was walking. I wonder if I actually stepped directly into a hole with that. It's like, you heard about people stepping into a sinkhole and then like, or no, not stepping into, their house gets enveloped, it just suddenly drops out, like a part of the street completely drops because there was like subsurface erosion that happened there. Something like that, and then there's like a cavity that's created, and then the gravity eventually just takes over, plop, and the whole floor just like sinks out. What the heck was I saying now? Yeah, I think that so it's just interesting to try to map that idea onto situations in real life, and I'm trying to kind of help myself teach it to myself by trying to understand how we all are kind of like these agents, and why does that? No, I'm gonna pause it there.